Good afternoon, everyone. So I hope all of you are acclimatized to our new mode of online class. So let's hope that this is just a temporary arrangement. Even I would like to take offline class. So till then we'll have to get adjusted to this. So I hope all of you are aware of this portal system which we have. So we have a response portal which you can see and a query portal. Both are different. And query portal should be used only to give reply to the questions which I raise in the class. Okay, only to the answer, like जो भी मैं क्वेश्चन क्लास में पूछूंगा उसके लिए आप आंसर करने के लिए यूज करना है. And whatever the doubts you have, whatever the queries you have, you should raise only in the query portal. If at all you are raising any questions or queries in the response portal, that will not be answered because that will not be visible to me all the time. ठीक है, क्वेरी में राइज करो, क्वेरी आ जाएगा. So that I can take those queries, whatever the queries you have. Response is only when I ask a question as an answer to my questions. You should use that. Okay, and do not send any other messages, any other chats in this. Okay, otherwise the response portal will be deactivated. Fine. So in the last class we discussed about the plate tectonics. We covered the major parts of plate tectonics. Then we started with volcanism. Okay, we covered what is volcanism, what is magma, types of magma, that is we have basaltic and granitic magma. Granitic magma is lighter in density, basaltic magma is heavier in density, and granitic magma is made up of, it's basically the constituent of the continental crust, whereas the basaltic magma is oceanic crust, right? And granitic magma is of lower temperature, basaltic magma is of higher temperature. ये सारा difference हमने देखा था. So then we also saw the different types of plate boundaries and the magma generation. What is the nature of magma, what is the way it is erupted, and the source of magma, ये सारा चीज़ें हमने वहाँ पर देखा था. So then we came to the distribution of the volcanic features and distribution of volcanoes across the world, and finally about the volcanic landforms. We are discussing about the different types of landforms. We have intrusive landform and extrusive landforms. We are discussing about the extrusive landforms. We have volcanic cone and three different types of volcanic cones: composite or stratovolcano, shield volcano, ash cinder cone. So other than volcanic cone, we have crater, caldera. हाँ, यहाँ पर एक चीज़ मैंने बताना भूल गया था, फ्लड बसाल्ट प्रोविंस. Okay, I'll talk about this flood basalt province. Then we discussed about hot springs, geyser, fumarole, mud volcano. Okay, we have all of these other different extrusive features. यहाँ तक हमने cover किया था. So volcanic cone is basically the conical shaped structure which is formed, है ना, and we have three different types of volcanic cones. कौन कौन सा था? Shield volcano, ash cinder cone, and then strato or composite volcano. This is shield volcano where the width is too much and the height is very less, okay, compared to the width. So that gives very it gives a kind of dome kind of structure, okay, it gives a kind of dome kind of structure. So that is what is shield volcano. Shield volcanoes are mainly formed by the basaltic magma. Then ash cinder volcano where even the height is less as well as the width is less, so and there is more domination of ash, cinder, debris and the ये जो gaseous as well as the smoke dust होता है ना, so that will get settled down over there and that results in the formation of cinder cone. And composite volcano, or which is also called a stratovolcano, so where it is too steep, है ना, it appears like a mountain, and stratovolcano it is called a strato because there would be alternative layers of magma and ash, okay, जो debris जो volcano से निकलता है, so that will get deposited here. And one of the most violent is composite volcano, and less violent is shield volcano, largest is shield volcano. And examples for shield volcano we discussed about Mauna Loa, Mauna Kea, and example of composite volcano is Mount Fuji, and example of ash cinder volcano, Taal volcano, okay, Taal volcano of Philippines. So crater is basically the depression, the saucer shaped depression which is found on the top of the volcano, we call it as crater. Okay, this is what is crater, and sometimes it gets filled with the water resulting in crater lake. Okay, and sometimes due to the very violent explosion a huge depression is formed, which is a very enlarged version of crater, we call it as caldera, right, and caldera में भी caldera lake बन सकता है. Then we have hot spring, geyser, fumarole. इन दो तीनों का difference तो हमने बताया था. So hot spring, the hot water comes out continuously. Okay, geyser, the water and steam, the superheated steam comes out of in a very high pressure manner, you know, at a regular interval. This is geyser. Fumarole, the gases, okay, just the gases and superheated steam comes out continuously without water. And most of the places where we have this active plate movement, you know, either the subduction or even along the mid-oceanic ridges or even along the geothermal zones, for example India, you will find the hot springs. Other than geysers and fumaroles are most common along the subduction zones and mid-oceanic ridges. So यहाँ पर एक चीज़ हमने डिस्कस करना है, flood basalt province. What is a flood basalt province? So wherever there is hot spot, there is rising of magma, right, and usually this magma rises along the oceanic floor. That is what we know, resulting in the formation of shield volcano, very large volcano, ये तो पता है. What if the same magma is from the hot spot is rising along a continental crust? Okay, it is rising along a continental crust which is thicker and lighter and it is more viscous in nature. In that case, the magma which is rising from the hot spot comes out and it spreads out over a very large area, particularly if it is coming out through a plateau. है ना? If it is coming out through a plateau where it flows very easily and smoothly for a very large area. So that is what we call it as the flood basalt province, which is formed by the flooding of basaltic magma on the continental crust. Usually it flows on the continental crust very smoothly, right? So that is what we call it as the flood basalt province. Okay, same hot spring, sorry, same hot spot, it is erupting over the continental crust. Best example है हमारा Deccan traps. When Indian plate was moving over the Eurasian plate, sorry, moving towards the Eurasian plate, when Indian plate was passing over the Reunion hotspot. Okay, let's say this is the Reunion hotspot and this is the Indian plate. Okay, when Indian plate was just above the Reunion hotspot, a huge amount of magma erupted. A huge amount of magma erupted which was basaltic in nature and that erupted on the Deccan plateau. Okay, Deccan plateau के ऊपर eruption हुआ था, because of which a huge sheets of basaltic province was created. That is our Deccan traps. Okay, Deccan province. Is that clear? So these are all extrusive features. So any doubts here? So if you have any doubts, please raise it in the query portal. And you can use the response portal to just reply yes sir, no sir, clear, as a basic communication other than the actual doubts, so that you feel connected here in the classroom. Now I can also see that हाँ ठीक है, all of you are following. So if all of these are clear, please say so. If you have any doubts, please raise it in the query platform. Yes, all clear. चलो, I think I have to dictate, right? इसका notes तो नहीं दिया था. So please write down. Volcanic landforms. इसके पहले का notes दिया था. हाँ, यहाँ तक तो हो गया था. Yes. Volcanic landforms, in that first one, extrusive features. Extrusive features. Which are formed by extrusive features, which are formed by, okay, sorry, extrusive features heading लिखो, उसके नीचे लिखो, these are the volcanic landforms formed by the cooling of magma above the earth's surface. Formed by cooling of magma above the earth's surface. Okay, in that the first one, volcanic cone. Volcanic cone. In that the first one, shield volcano. Shield volcano. Okay, points wise लिखो, point wise. First point. It is formed by a very fluid basaltic magma. It is formed by very fluid basaltic magma. Next point. they are found along, or it is found along, they are found along, जो भी आपने लिखा है, so it is found along hotspots, due to mantle plumes, hotspots due to mantle plumes. Next point, they are largest of all volcanoes, on the earth. The slope is not steep. Example, Mauna Loa, Mauna Kea. Second one, Ash Cinder volcano. Ash Cinder volcano. They are formed by the accumulation of loose particles. Around vent. Accumulation of loose particles around vent. Next point, they are dominated by ash, debris and other volcanic material, with less lava. Example, Taal volcano of Philippines. Third one, composite or stratovolcano. They are formed by the accumulation of viscous magma. They are formed by the accumulation of viscous magma, which is of bit lower temperature, which is of bit lower temperature, and less fluidity. Less fluidity. Next point, they are the steepest of all the types. They are the steepest of all the types. Then the alternative layers of alternative layers of ash and magma, sorry lava, bahar hai na lava, ash and lava alternative layers of ash and lava provides for composite structure. Example, Mount Fuji. Mount Fuji of Japan. Mount Fuji of Japan. So next one, this is first one, volcanic cone. Second one is crater. Crater. For crater you can write this figure. So this is crater. So crater क्या है? Crater is not a different volcano itself. It is part of the volcano. Volcano का जो upper most part होता है ना, जहां पर depression रहता है, that is what is crater. Simple है. It is basically the part covering the mouth of the volcano from which the magma erupts. उसको बोलते हैं crater. Right? So what is a crater? Depression at the mouth of volcanic vent. Depression, you can add funnel shaped depression. Okay, funnel shaped depression at the mouth of volcanic vent. Full stop. When filled with water, it results in crater lake. When filled with water, it results in crater lake. And third one, caldera. Caldera. So Palak has a doubt about caldera. Let me just explain caldera again. So let's say this was the volcano with crater. Okay, this was the volcano and this was the crater, earlier crater. And this was the mouth of the volcano and this is the vent. Vent provides connectivity to the magma chamber, right? Vent connects the volcano to the magma chamber, right? So this is magma. From this lava comes out, right? Sometimes this vent, okay, this is called as vent. Sometimes this vent gets blocked by the cooling of magma here. Magma पूरा erupt होके जो finally बच गया ना, so that cools down here and it blocks the vent. because of which there is a continuous build up of pressure. बाकी कुछ दिन के बाद में, कुछ महीनों के बाद में जो मैग्मा बिल्डअप होता है, so it is continuously building up, and after sufficient build-up of pressure, it violently explodes. So in that case, in case of a very violent explosion, the entire top portion of the volcano collapses and becomes a very wide depressions. Okay, very wide depression like this. This was the earlier portion. This is the present portion. This very enlarged portion we call it as caldera. Caldera can also get filled with water, resulting in caldera lake. Simple. Okay, please write caldera. It is a greatly enlarged depression formed due to violent eruption of volcano resulting in the subsidence of much of volcano It is caldera. Full stop. When water is collected, it results in caldera lake. So next, flood basalt province. So few of you are asking about flood basalt province. I will explain again. See, wherever there is a hot spot, magma is generated from the mantle portion, right? So usually hot spot along the sea floor, along the oceanic floor, results in the formation of a shield volcano. Okay, results in the formation of shield volcano. For example, the volcanoes of Hawaii Island. The entire Hawaii Islands surrounding में जो भी islands है ना, they are all formed by shield volcanoes only. The eruption of magma along the oceanic floor. If at all the same magma erupts on a continental crust, okay, if it is erupting on continental crust, the magma has the capacity to even drill into the continental crust also. Continental crust से भी ऊपर आ सकता है. Magma is so powerful. Whenever magma rises, that is along hot spots, okay, along hot spots I am talking about. Hot spots के यहाँ it is rising along the continental crust, and if that magma is very fluid in nature, for example basaltic magma, usually which is the case in case of mantle plumes, this magma flows very easily for a very long distance. It will not accumulate as it resulting in the formation of cone. Cone नहीं बनेगा यहाँ पर, right? It flows and forms sheets of basaltic lava over a very large area. If you actually see this, ऊपर से देखा तो ऐसा लगता है कि basaltic lava से पूरा plateau बना है. It appears like the entire plateau is made up of basaltic lava, but actually if you dig it, it is only a very thin layer. उसके नीचे actually it is totally granitic crust in nature, because ये continental crust है, उसके ऊपर basaltic magma का eruption हो गया. Why? Because the continental crust has moved over a hot spot. For example, when Indian plate was moving over the Reunion hot spot, when Indian plate was moving towards the Eurasian plate, it encountered Reunion hot spots in between. वहां पर when it was standing on the Reunion hot spot, a huge amount of basaltic magma erupted in the entire portion of the southern part of India. वहां पर Deccan plateau था. Plateau region है, hard rock है, that helps in the faster flow of this basaltic magma, है ना, अच्छे खासा distribute हो जाएगा. And there was also some kind of steepness was there along the Western Ghats. ये सारा region है ना, it resulted in a kind of step like topography over there because of the spreading of the entire magma over the plateau region. Such kind of spreading of the basaltic magma over a plateau region, we call it as the flood basalt province, क्योंकि the basalt has flooded over the entire plateau region. Example, the entire Deccan plateau. Entire Deccan plateau, earlier before it was coming over the Reunion hotspot, it was not volcanic in nature. अभी वो volcanic हो गया है because of the basaltic layer which it has, which was erupted when Indian plate was moving over the Reunion hotspot. Other than that, the Columbian plateau of USA, that is also flood basalt province. Is that clear? Please write. When a highly fluid lava erupts over a plateau region, it flows for a long distance, covering thousands of square kilometer area, Example, Deccan plateau, Columbian plateau, etc. So next, hot spring. Hot spring or thermal spring. Hot spring or thermal spring. First point, when water sinks deep enough, beneath the surface to be heated by a hot spot, or a magma chamber, or a geothermal belt, it rises to the surface, it rises to the surface without any explosion, resulting in hot spring, without any explosion resulting in hot spring. Next point, the water contains dissolved minerals, the water contain dissolved minerals and has medicinal value. And has medicinal value. Example of hot springs: hot springs of Iceland, hot springs of Iceland, USA, इंडिया, इंडिया में कौन सा है? मणिकरण, मणिकरण, तातापानी, मनाली, मणिकरण, तातापानी, मनाली, राजगीर, etc. Then geyser, geyser, these are fountains of hot water. These are fountains of hot water and superheated steam, fountains of hot water and superheated steam ejected intermittently at regular intervals, with explosion, that is geyser. Okay, example, geysers of New Zealand, Iceland, geysers of New Zealand, Iceland and USA. USA में we have Old Faithful geyser, which erupts every 65 minutes, Third one, fumarole. It is a continuous jet-like emission, of steam and other gases, continuous jet-like emissions of steam and other gases without water. Of course, steam is water in gaseous form. I am talking about the liquid water, without liquid water. Then mud volcano. It involves the eruption of mud mixed with water and gases. Eruption of mud mixed with water and gases and may not contain magma. Example, Baratang Island. Baratang Island of Andaman Nicobars. So this is all about extrusive features. Karthik has a doubt? If basaltic magma is denser than granitic, then how is basaltic more fluid? See, the fluidity is not depend upon the density. Okay, not always. ऐसा नहीं कि light है तो ज़्यादा fluid रहेगा. That is our imagination. Fluidity of magma depends upon the temperature of the magma. Okay, how hot it is, how mobile it is. It is separately, it is not necessary that it has to be decided by the density of the magma. ठीक है? And moreover, density of granitic magma and basaltic magma both are not that great. I know that too heavy है तो ज़्यादा flow नहीं रहेगा, बहुत light है तो flow रहेगा, वो तो मैं समझ सकता हूँ. But the difference of density is not that great between the granitic magma and basaltic magma that this density is causing the fluidity. No. Density, the difference in density is not causing the fluidity. Fluidity is caused by temperature. Heat ज़्यादा है, higher temperature है, that is causing the fluidity. Example of fumaroles of Iceland. Iceland में है fumaroles of Iceland. ठीक है? So let me tell you about intrusive features. Intrusive features इसमें बहुत सारा है, सारा इंपॉर्टेंट नहीं है, 5 याद रखो काफी है. 5 major intrusive features. One is batholith. Batholith. Second one is laccolith. Batholith, laccolith, lopolith. Third one is lopolith. 3 lith हो गया. Batholith, laccolith, lopolith. Then sills and dikes. Sills हो गया and dikes. Okay, 5 intrusive याद रखो. पहले बात है कि intrusive क्या होता है? What exactly are intrusive landforms? These are basically the landforms formed by the cooling of magma below the earth surface. Cooling of magma below the earth surface. So basically all of them are intrusive igneous rocks, right? It results in the formation of intrusive igneous rocks. But उसका shape अलग अलग होता है. Depending upon the shape, depending upon the size, we have different names. बाकी rest everything is magma cooled down below the surface in all the different possible shapes, like this. Okay, basically why would the magma cool down below the surface? Because it is getting some space below the surface, है ना? Surface के नीचे उसको space मिल रहा है, जगह मिल रहा है, and the temperature of the magma is not that high कि it is too much of pressure है उसके अंदर बाहर निकल के आना है. ठीक है? एक तो मैग्मा का प्रेशर कम है, दूसरा there is a space in the lithosphere, here and there the cracks, the faults, the blocks in between the different rocks. So it will get some space and it will accumulate over there and it will cool down over there, resulting in the formation of intrusive volcanic landforms. All of them are the magma which is cooled down below the surface only. If it cools down like a huge dome shaped structure, बहुत बड़ा ऐसे डोम शेप स्ट्रक्चर में कूल डाउन हुआ तो इट इज कॉल्ड एज batholith. A huge dome shaped structure, very irregular रहता है ऐसे. Overall you can see a dome shaped huge structure, बहुत बड़ा होता है. They are called as batholith. So usually when magma cools down in a very large quantity, over a very large area, it results in the formation of batholith. Batholiths over a long period of time undergoes upliftment because of the internal forces, है ना? जो भी forces हमने पहले discuss किया है ना, it caused the upliftment of batholith over a long period of time. When it rises above, that is how we will see the hills of rocky, है ना? बहुत बड़ा ऐसे rocky का hills बन जाता है, या by the cooling of magma at such deeper depths, it might result in the formation of one of the very valuable rocks like granitic rocks. After upliftment it becomes an outcrop and then it is exposed. That is how they are quarried, right? So that is batholith. Huge irregular shaped dome, we call it as batholith. Then what is laccolith? लैकोलिथ क्या होता है? सो लैकोलिथ इज ए काइंड ऑफ मशरूम शेप्ड बॉडी. इट इज मशरूम शेप्ड बॉडी. ओके, ऐसे एक छाता जैसे ऊपर रहता है एंड विथ ए कॉन्ड्यूट. बट हियर द डिफरेंस बिटवीन लैकोलिथ एंड बैथोलिथ इज दैट it maintains its connection with the magma chamber. There is still an active connection with the magma chamber. यहां पर magma supply बंद हो गया, magma आके यहां पर cool होके खत्म हो गया. But here the laccolith is, even though this is almost dome shaped, it will have a conduit giving it a mushroom form, and second thing is it maintains its connection with the magma chamber. That is what we call it as the laccolith. Third one, lopolith. Lopolith, can you see it is a kind of saucer shaped depressions. The accumulation of magma along the horizontal strata, okay, along sedimentary layers हो सकता है या sedimentary strata हो सकता है. In that, if the magma is accumulated in a saucer shaped depression, it results in the formation of lopolith. यहां पर accumulate होके cool down हो गया, फिर lopolith बन गया. The same magma has accumulated in the form of sheets, horizontal sheets between the sedimentary layers. पूरा ओके ऐसे कंटिन्यूस शीट बन जाता है इन ए कंटिन्यूस स्ट्रेट लाइन along the sedimentary layers. Okay, usually this is how the sedimentary layers are deposited, right? So in that, if they are getting deposited in a horizontal manner, it is called a sill. If they are deposited in a vertical wall like structure, we call it as dike. If the magma is rising up like a vertical wall, it is cooling down below the earth surface. Okay, यहाँ पर नीचे ऐसे ही cool down हो गया है, but it is cooling down in a vertical wall kind of structure. We call it as dike. Over a period of time, all of these intrusive features can undergo upliftment and can rise above the water, above the surface. Possible है. Okay, that is we require the thrust from the inner part. So 5 हो गया. Irregular dome shaped structure batholith, mushroom shaped structure with a conduit, maintaining connection with magma, laccolith, saucer shaped depression, lopolith, horizontal sheets, sill, vertical walls, dike. These are intrusive features. Okay, इसके ऊपर डायरेक्ट क्वेश्चन नहीं आने वाले. They are not going to ask you what is a batholith, what is a lopolith, ये सारा बताओ. So they might ask in general about the volcanic features. What are volcanic features, volcanic landforms क्या होते हैं, and what are the different types of intrusive and extrusive features. You just have to write names and one line explanation with a simple figure. That would be sufficient. इससे ज़्यादा डिटेल में जाने का जरूरी नहीं है. Okay, write this simple figure. ये वाला फिगर लिखो and then write the first one, batholith. Batholith. These are long irregular. Yes, Alaska is also known as the land of fumaroles. That's right. Alaska may be hay. Okay, batholiths are the long irregular dome shaped structure formed by the cooling of magma along deeper layers of earth or lithosphere, along deeper layers of lithosphere. Second one, laccolith. Laccolith. These are mushroom shaped features formed due to intrusion of magma along bedding planes. Third one, lopolith. When magma solidifies, in saucer shape along a shallow basin, it results in lopolith. Then phacolith. It involves, चलो फैकोलिथ छोड़ो, माइनर है, जरूरी नहीं उसके बारे में मैंने बताया नहीं, सो फैकोलिथ छोड़ो, सिल्ब लिखो, राइट अबाउट सिल्ब. Intrusive igneous rocks formed usually parallel to bedding planes. थोड़ा स्क्रीन दिखाइए. Parallel to bedding planes. Of sedimentary layers. यानी ये स्क्रीन दिखा दिए, कैमरा में दिखाइए. Of sedimentary layers, sill, dike. So yes, we can say in a way that the shield volcanoes are the extension of shield volcanoes on the continent. That results in flood basalt province. That's totally right, Amit. Dike. What is dike? Wall-like formations of sedimentary rocks. Wall-like formations along sedimentary rocks due to the intrusion of magma. Okay, wall-like formations along sedimentary rocks due to the intrusion of magma. Okay, these are the intrusive features. See, one of the most destructive volcanic eruption in the history, in the recent times. Okay, historically there are few other destructive volcanic eruptions, particularly ये जो हमारा USA में, USA is one of the most destructive volcanic eruption happened along this volcano. This is St. Helens. St. Helens volcano. Okay, it was in 1980 it erupted. It erupted in 1980. So what happened in this eruption? See, this was the volcano which was giving out smoke. इससे smoke आ रहा था बाहर से कभी कभी. So that is an indication that it is about to erupt. ठीक है? So all the geographers, geologists and all the interested people who wanted to study this, they were all surrounding this volcano. है ना, पूरा volcano के surrounding में आके अगल बगल में आके बैठ गए थे. They wanted to do research over there. Okay, and they assumed that the volcano will explode like this in a vertical manner. Okay, they assumed a vertical explosion and they assumed a perimeter based on this, and they were sitting. Okay, बहुत दूर से ही बैठ के observe कर रहे थे. But this volcano did not explode in a vertical manner. One of the main volcanic vent was blocked. इसका जो मेन वॉल्केनिक वेंट था ना, ये ब्लॉक हो गया था. उसके वजह से इट एक्सप्लोडेड इन ए हॉरिजॉन्टल मैनर लाइक दिस. वर्टिकल एरोजन हुआ तो ऊपर चला जाता एटमॉस्फेयर. टिल द एंड ऑफ द एटमॉस्फेयर इट वुड हैव गॉन. एंड सिंस इट एरप्टेड इन ए हॉरिजॉन्टल मैनर for like thousands of square kilometer of area around, this entire area was totally devastated. Can you see there is this huge forested area पूरा था, अभी पूरा barren land हो गया. And because of the lateral eruption, the entire one side of the mountain collapsed. And now this is the St. Helens. So that is one of the deadliest volcanic eruptions of USA. It resulted in the largest landslide recorded in history. The entire one side of the mountain came off and a huge amount of flooding happened because of the melting of this ice. Many people died of course, and many of the geographers who were there in the surrounding vicinity, जो इस तरफ थे वो सारा बच गया, इस तरफ जो भी थे most of them died here. That is St. Helens, 1980. एक और वॉल्केनो है इंडोनेशिया में, क्राकटोवा. सुना है क्राकटोवा? क्राकटोवा वॉल्केनो is there between Sumatra and Java. Okay, there are two main islands, Sumatra and Java. वापस जाके एक बार चेक करना कहां पर है. So in between that, along the oceanic floor, we have this Krakatoa volcano. So that erupted in 1883. It erupted in 1883. So this Krakatoa volcano was so violent. It was so violent. The sound of eruption, the sound of explosion was heard in Australia. Okay, इंडोनेशिया में एक्सप्लोजन हुआ था, ऑस्ट्रेलिया में सुना था. एंड इट क्रिएटेड ए ह्यूज सुनामी विच रीच्ड इवन अफ्रीका. अफ्रीका तक पहुंचा था द वॉल्केनिक एरप्शन. उसकी वजह से जो सुनामी आया था. दिस इज वन ऑफ द डेडलिएस्ट वॉल्केनिक एरप्शन वी हैव रिकॉर्डेड इन द रिसेंट हिस्ट्री. ऑफ कोर्स दैट टाइम देयर वाज नो वीडियो, फोटोग्राफ. दिस इज जस्ट द पेंटिंग जो रिप्रेजेंटेशन है. वन ऑफ द मोस्ट डेडलिएस्ट. एंड इंडोनेशिया में क्यों होता है? इट्स बिकॉज इट इज अलोंग द सबडक्शन जोन. इंडियन प्लेट इज सबडक्टिंग बिलो द एक्सटेंडेड पोर्शन ऑफ यूरेशियन प्लेट ओवर देयर. ओके, लाइक दिस देयर आर मेनी वॉल्केनोस. बहुत सारा कहानी है, तो विल टॉक अबाउट दैट इन मैपिंग पार्ट. Okay, we'll try to map, we'll try to locate some of the important volcanoes of the world. Okay, तब बता दूंगा. ठीक है, and in this PPT, so I have a small documentary on this St. Helens volcano, volcanic eruption. So छोटा सा documentary है, आप बाद में देख लेना. So now any doubts? All clear? Volcanism. Barren Island is not intraplate, it is interplate between Indian and Eurasian plate. उसके बीच में along the Java Trench. ठीक है, it is not intraplate, it is interplate. Intraplate में तो volcanic usually नहीं होता है. It should be only due to hotspot. Barren Island is not because of hotspot. चलो, we'll move on to the next topic, geomagnetism. चलो ठीक है, I'll write the difficult words on different spellings dictate करते समय and try to write it on the board. Types of eruptions, ये सारा तो ज़रूरी नहीं है जनरल स्टडीज़ के लिए, so जितना काफ़ी है we have covered. चलो आगे बढ़ते हैं. Geomagnetism. What is geomagnetism? Before we go to the geomagnetism, let's talk about magnetism. Magnetism क्या होता है? So if you have seen a magnet, कोई भी मैग्नेट होगा, it will have usually two poles, north pole, south pole. Magnetic का अंदर होता है, okay, two different opposite poles, and surrounding that magnet there would be magnetic field like this. Surrounding any magnet there would be magnetic field. Surrounding electric charge there would be electric field. You bring two different electric charges, if they both are different they will attract, right? They will try to move towards each other, creating the potential difference बोलते हैं. If they are same, they are trying to move away, that is electric field, electric charge के surrounding में जो होता है. In the same way, wherever there is a magnetic material, surrounding any magnetic material there would be magnetic field. जैसे magnet होता है, you might have seen magnets, है ना? So When you bring two magnets together, why do they get attracted towards each other? Because they are coming under the magnetic field of each other. You bring two north pole, they will repel each other. Bring two south pole, they will repel each other. Bring north pole and south pole, they will attract each other. That is what is magnetic field. We know that magnetic field, right? This is magnetism. Geomagnetism is basically the magnetic field associated with Earth. Magnetic field associated with Earth. That means similar to a magnet, even Earth has a magnetic field around it, like this. That means the entire Earth behaves like a huge bar magnet. It behaves like a huge bar magnet with magnetic field surrounding the Earth. So that magnetic field which surrounds the Earth is called as geomagnetism. What is geomagnetism? Geomagnetism is the magnetic field around the Earth. वो कैसे हुआ था, क्या हुआ था, ये सब बाद में. पहले बात समझो. Magnetic field would be there around any magnetic material. In the same way, Earth के surrounding में there is a huge magnetic field which makes the Earth to behave like a huge bar magnet. जो bar magnet रहता है ना with north pole, south pole. In the same way, Earth also behaves like a huge bar magnet, and even Earth has north magnetic pole and south magnetic pole. Earth के अंदर भी there is north magnetic pole and south magnetic pole. Of course, this is different from geographical pole. जो first unit में हमने देखा था, the geographical north, geographical south, so उससे अलग है. Magnetic north, magnetic south is basically similar to the bar magnets, magnetic north and magnetic south. Every magnet will have its own north pole, south pole. And in the same way, Earth also has north pole and south pole in the magnetic field. So that magnetic field surrounding the Earth is called as geomagnetism. ठीक है? That is what. Now let's come to how. How or why, both are same in this case. How did Earth acquire magnetic field? Or why did Earth acquire magnetic field? It is due to a property called as electromagnetism. It is due to a property called as electromagnetism. तो अभी मैग्नेटिज्म हो गया, जियोमैग्नेटिज्म को हो गया, इलेक्ट्रोमैग्नेटिज्म क्या है? व्हाट इज इलेक्ट्रोमैग्नेटिज्म? इसका कहानी अलग है. Let's say that this is an electric wire. Okay, this is electric wire through which electric charges are in motion. Electric charges are moving in this direction. Whenever electric charges are in motion, what do we call it as? We call it as electric current. Simple. Electric current is basically the movement of charges. Okay, I am not going into too detail here क्योंकि बहुत सारा students है who are not from science background, they might not understand. Okay, very simple manner, let's understand this. Movement of electric charges, charged particles when they move, we call it as electric current. If this is the electric wire in which the electric charges are moving in this direction and this is the direction of electric current, this movement of charges generates magnetic field around this in this manner. Movement of electric charges in electric wire generates magnetic field around the electric wire in which it is moving. If the electric charges are moving in this direction and the electric field is happening in this direction, that is what we call it as electromagnetism. Electromagnetism is basically the magnetic field generated by the movement of electric charges. Wherever there is electric charges in motion, around that there would be magnetic field. That type of magnetism we call it as electromagnetism. Earth has acquired the magnetic field due to the property of electromagnetism. Electromagnetism के वजह से आया है अर्थ का magnetic field. यहां पर कौन सा इलेक्ट्रिक करंट है अर्थ के अंदर? We know that for electromagnetism we need electric current. If Earth's magnetic field is generated by electromagnetism, Earth should also have electric current, right? So ये current कैसे आ गया? Two important sources. One is rotation of Earth. Rotation of Earth. Why? How come rotation of Earth is generating electric current? These are three layers of the Earth's interior. The inner core is totally solid, whereas outer core is liquid. Inner core is totally solid and outer core is liquid. Outer core is actually liquid, and what exactly it is made up of? It is made up of निकल एंड आयरन, राइट? उसमें सबसे ज्यादा है आयरन, एंड द आयरन इन द आउटर कोर is actually in the liquid form. Whenever it is in the liquid form, it tends to move freely, right? And these iron particles, while they are under motion due to the friction, they acquire charges. We have iron ions. Okay, what is an ion? When any of the particular element is losing an electron or gaining an electron, we call it as ion. So it is basically iron ions which are in motion in the Earth's outer core. Ion is similar to charge, and the movement of iron charged particles in the outer core generates electricity over there. Electricity matlab basically it is the movement of charges in a very large scale. The iron charged particles in the outer core, they are moving in a very large scale in outer core. Why they are in motion? Because the earth is not stationary, it is totally rotating. जैसे earth rotate होते होते इसका all the different layers are also rotating along with this, right? But inner में एक layer है which is liquid in nature. In that there are iron charged particles, and due to the rotation of earth, even that liquid charged particles, the iron charged particles are also continuously in motion. So basically the charges are in motion, and that generates magnetic field here. The charged particles in the liquid outer core which are in motion generates electric current, and surrounding that electric current we have the magnetic field, right? So what is causing the motion of iron charged particles? It is the rotation of earth. There is also second reason. There are convection currents even in outer core. आउटर कोर के अंदर भी कन्वेक्शन करंट्स है, क्योंकि दिस इज टोटली लिक्विड एंड देयर इज अ ह्यूज अमाउंट ऑफ एनर्जी इज बीइंग रिलीज्ड हियर इन द आउटर कोर, राइट, which generates convection currents in this manner. That is movement of molten magma, the cyclical movement of molten magma like this. थोड़ा सा zoom in कर दीजिए. Okay, this is mantle, this is outer core, inner core. Okay, inner core to solid hai, outer core is liquid, and in that particularly we have iron particles which are iron charged particles which are under motion. One reason due to the rotation of earth, second reason due to the convection currents which are generated due to the release of heat. And these convection currents keeps these iron charged particles in continuous circular motion, cyclical motion like this, and that is what is electric current. Charged particle motion में तो electric current हो जाएगा, and surrounding electric current we have magnetic field which we call it as the electromagnetism. So इसलिए जो भी magnetic field generate होता है अर्थ के surrounding में, it develops in this manner. It is getting developed in this manner and surrounds the entire earth like that, which we call it as the earth's magnetic field or geomagnetism. Is that clear? So please write about this. The magnetic field associated with earth is called as geomagnetism. Magnetic field associated with earth is called as geomagnetism. Next paragraph. Earth has an outer rocky mantle. Earth has an outer rocky mantle below which there is liquid outer core. Below which there is liquid outer core which surrounds the solid inner core. Full stop. It is considered that the motion of charges that is iron in the liquid part of earth's core generates magnetic field. Next paragraph. The motion of charges is caused by first one, rotation of earth, second, the heat rising from earth's central core, results in the generation of convection currents, of molten material in the outer core. in the outer core. Next paragraph, motion of ions in this molten material would produce an electric current through the earth's core, that results in magnetic field around the earth. That is geomagnetism. Okay, let's take a short break, and after the break we will continue about the same topic, geomagnetism, and a few other phenomena associated with geomagnetism, including auroras. Okay, we will discuss about auroras also after the break. So we are talking about geomagnetism. So geomagnetism is basically the magnetic field associated with the earth. Simple terms में earth के surrounding में magnetic field है, that is what we call it geomagnetism. So क्यों होता है? Because of the movement of charges in the outer core of earth. In the outer core, being liquid in nature, okay, it is rich in iron. The iron charged particles, when they are in motion, that is basically equivalent to electric current. So wherever there is electric current, surrounding that there would be magnetic field through a phenomenon called as electromagnetism. So in the same way, earth also is surrounded by magnetic field. The magnetic field generated by the electric current which is passing through the earth's outer core. So that is what we call it as electromagnetism and the magnetic field. So Ankit has a doubt about the generation of convection currents in the outer core. How the convection currents are generated in the outer core? यार इसमें कुछ ज़्यादा mechanism नहीं है. So we just have to understand. So what exactly are these convection currents? Convection currents are the currents of magma, molten rock material. Outer core is already molten rock material, है ना, पूरा molten material ही है. So now it requires amount of heat. As heat passes through these layers, it causes the movement of magma in a cyclical manner. This movement of magma in a cyclical manner in current form, we call it as convection currents. The same convection currents which we saw in mantle also. Okay, that involves the whole of mantle. यहाँ पर outer core में रहता है convection currents. We call them as convection currents of outer core. And convection currents of outer core is basically again the charged particles which is causing it to move continuously, and that generates magnetic field around the earth. We call it as geomagnetism. Next let's talk about a topic called as paleomagnetism. Paleomagnetism. What is paleomagnetism? What do you mean by paleo? Paleo means old. Paleo means old. So paleomagnetism involves the study of Earth's magnetic field in the older times. पुराना टाइम का जो मैग्नेटिक फील्ड था ना, उसको जो स्टडी करने का ओवरऑल प्रोसेस है, वी कॉल इट एज पैलियोमैग्नेटिज्म. सो हाउ कैन वी स्टडी द अर्थ्स ओल्डर मैग्नेटिक फील्ड, मतलब द मैग्नेटिक फील्ड ऑफ द अर्लियर टाइम्स. दैट कैन बी स्टडीड by analyzing the rocks of the oceanic crust. The Earth's magnetic field in the older times, है ना, पुराना टाइम में जो magnetic field था, so we can understand by studying the rocks of oceanic crust. The rocks of oceanic crust are mainly made up of various different minerals. In that particularly we have the minerals of iron, titanium and various such minerals which are magnetic in nature. we call them as magnetic minerals. What are magnetic minerals? Those minerals which get oriented in the magnetic field. You bring them in the magnetic field, they get oriented in the direction of magnetic field. So such minerals we call it as the magnetic minerals, and there are many such magnetic minerals in the Earth's oceanic crust. For example, the iron and titanium. So you take a cross section of the oceanic crust and try to study the magnetic minerals in these. Okay, try to study the magnetic minerals in these. You can see that these minerals are usually aligned in a particular direction. Like this. And this direction in which they are aligned right now is the direction of the magnetic field which was existed when that magma was actually about to form. The magma was resulting in the formation of rock. Let me explain. So let's say that this was the portion of magma earlier, बहुत पुराना time है. Let's say that 1 million years ago जो magma था, and the same magma contained some of the magnetic minerals like iron, titanium, etc. When this magma was in molten form, these magnetic minerals, they are not aligned in the magnetic field, whatever the magnetic field which was there. What is this alignment of magnetic field? तो उसका मतलब क्या है? So there is a magnet. Okay, let's assume that there is a magnet, there is a bar magnet. तो इसके surrounding में there would be magnetic field, right? You bring another mineral which is magnetic in nature, for example iron or any other mineral which is magnetic, जो magnet को लेके attract करता है ना, you bring them, it gets aligned in the direction of the magnetic field. Magnetic field के direction में align हो जाता है. So that is what is alignment of any magnetic minerals in the direction of magnetic field. But in case of those minerals in the magma, usually these magnetic minerals are not aligned. They are freely moving in all the possible directions like this. They move very freely in all the possible directions. However, as this magma freezes and becomes a rock, all of these magnetic minerals get aligned in a particular direction like this. That's because this is the direction of Earth's magnetic field. Earlier, in case of magma, these magnetic minerals are freely moving in all the different possible directions. They are not aligned. But once they start to become freeze, once they start to become hard rocks, the same magnetic minerals, all of them get aligned in a particular direction of the Earth's magnetic field. Because Earth's magnetic field is everywhere surrounding the Earth. It's there even along the oceanic floor. Even along the oceanic floor, it is experienced. That is why the Earth's magnetic field influences these magnetic minerals to get aligned in that particular direction. So if you take out the oceanic rocks, you can actually see that these minerals, the magnetic minerals of these oceanic rocks, are aligned in the direction of Earth's magnetic field, which we call it as the stable magnetism which these rocks have acquired. इससे क्या होगा? Like you take out the rocks in any particular oceanic floor, that should show the direction of the Earth's magnetic field, right? यही समझ के we took the rocks of oceanic floor somewhere in other different part, and to our surprise we saw that in this rocks the magnetic minerals are aligned in totally different directions. Of course all of them are in the same one particular direction, but they are in totally different direction than that of the earlier rock. यहाँ पर तो इस direction में था, and if you see the alignment of these magnetic minerals in other type of the other part of the ocean, you find that the rocks show the magnetic field in this particular direction. How is it possible? How is it possible? While one part of the ocean and its rocks show the Earth's magnetic field in one particular direction, whereas other part of the ocean and the rocks show the magnetic field in entirely different direction. So it is not because the oceanic floor is moving. ओशनिक फ्लोर मूव होते हुए इवन द रॉक्स आर चेंजिंग, जो भी पर्टिकुलर डायरेक्शन में कहीं दूसरी जगह में जाके डिपॉजिट हो चुका होगा, बट द रॉक्स वंस दे आर फॉर्म्ड, एक बार मैग्मा से फॉर्म हो गया उसके बाद में वो मिनरल्स दे विल नॉट चेंज देयर मैग्नेटिक अलाइनमेंट, दे आर फ्रोजन इन द डायरेक्शन ऑफ अर्थ्स मैग्नेटिक फील्ड. So that means the rocks do not change their position. That means the Earth's magnetic field has changed over a period of time. The direction of the Earth's magnetic field has changed over a period of time. And to study the change in the direction of Earth's magnetic field over a long period of time, we call it as the paleomagnetism or fossil magnetism. Why? Because we are studying the rocks which are fossilized. Now, why there is a change in the Earth's magnetic field? That's because of the reason behind the generation of Earth's magnetic field. Earth's magnetic field is generated by the liquid outer core, the convection currents, and the rate of this movement of convection current is not necessary that it has to be constant. ये constant नहीं रहता है, कभी कभी बहुत ज्यादा हो जाता है, कभी कभी बहुत कम हो जाता है, because of the generation of heat. It entirely depends upon the generation of heat. When it is too high, there would be a stronger convection currents. There would be too low, there would be weaker convection currents. Overall, even though it maintains stability, but there would be minor variations in the convection currents, and so is the direction of the magnetic field. Generally, even the Earth's magnetic north pole and south pole should be in the same direction as that of geographical north pole and south pole, because Earth rotates like this along the geographical pole, right? But because of these minor variations within the convection currents, there is a mismatch in the alignment of magnetic north pole and south pole and the geographical north pole and south pole. They are not in the same direction. Even if you see, even now, okay, this is geographical north pole and south pole, and this is magnetic north pole and south pole. There is a slight mismatch. Magnetic north is not exactly on geographical north, and magnetic south is not exactly on geographical south. And ये जो magnetic north pole and south pole है ना, it is not constant. It keeps changing. It keeps changing its position, which we call it as the polar wandering. We call it as polar wandering. That is the movement of magnetic poles. Magnetic poles of Earth is not totally constant. They keep moving. That is why if you analyze the rocks of the oceanic crust, some of the newer rocks, they show an entirely different direction than the older rocks. उनका डायरेक्शन ही अलग हो जाता है. इट्स नॉट बिकॉज ऑफ द मूवमेंट ऑफ द रॉक्स, इट्स नॉट बिकॉज ऑफ द मूवमेंट ऑफ ओशनिक रॉक्स, क्योंकि वंस द डायरेक्शन ऑफ द मैग्नेटिक फील्ड इज फिक्स्ड इन द molten rock material which is starting to freeze, its direction will not change. But it is because the direction of the Earth's magnetic field itself is changing continuously. It is not constant. So that is why if you analyze the rocks of the entire oceanic crust, you will find the direction of the Earth's magnetic field in all the possible different directions. And using that we can come to conclusion in which period, in which direction the Earth's magnetic field was. That entire study we call it as the paleomagnetism or fossil magnetism. Is that clear? I told you Earth's magnetic field is not same as, Earth's magnetic pole is not same as the geographical pole, right? Let me just show you. Okay, if you have atlas, please open atlas with polar regions. Polar region में of course you can see at the center the North Pole. At the center, can you see the North Pole? This is North Pole, right? This is actually North geographical pole. And can you see this is North magnetic pole. Both are not in the same position. एक ही position में नहीं है. They are very wide apart. Right? And come to the South Pole. Antarctica में देखो. This is South Pole, this is geographical pole, and this is South magnetic pole, right? Both are not coinciding. Why they are not coinciding? Because it is not necessary that they have to coincide. There is a slight variation in the generation of convection currents always, so that's why they keep moving from one position to another, which we call it as polar wandering. And that polar wandering is recorded in the oceanic rocks. By studying the oceanic rocks, we can come to conclusion about the Earth's historical magnetic field, which we call it as the paleomagnetism or fossil magnetism. Is that clear? So that is what we call it as the paleomagnetism or fossil magnetism. So हमने तो यहाँ पर तो we did not stop. We wanted to discover more. And we started to analyze the oceanic rocks in much detailed manner. We went to much older rocks, and to our surprise, in few of the rocks we found that the magnetic minerals are aligned in totally opposite direction. Which suggests that the Earth's magnetic field was in totally opposite direction. देखो यहां पर दोनों का डायरेक्शन सेम ही लगता है, बट हियर इट इज पॉइंटिंग टू दिस इज नॉर्थ एंड दिस इज साउथ. हियर दिस इज नॉर्थ एंड दिस इज साउथ. दे आर पॉइंटिंग इन ऑपोजिट डायरेक्शन. Few of the much older rocks, if you go, they are actually pointing totally in opposite direction than the present one. How is this possible? That's possible because of a phenomenon called as magnetic reversal. Magnetic reversal. So once in a very long period of time, around 200 to 300,000 years, around every 200 to 300,000 years, we have seen that Earth's magnetic field has undergone reversal. What do you mean by reversal? In the north geographical pole you will have south magnetic pole. In the south geographical pole you will have north magnetic pole. अभी north pole के पास में है, south pole के पास में. I'm talking about the magnetic pole and geographical pole. In case of reversed magnetic field, near to the north geographical pole you will have south magnetic pole. Near to the south geographical pole you will have north magnetic pole. That is what we call it as magnetic reversal, and that is recorded even in the oceanic rocks. That historically, if you go back to a very long period of time, you can see those rocks which are giving the evidence of reversed magnetic field. What causes the reversal of magnetic field? Same, the movement of convection currents. Here the convection currents are moving in this direction, What if they stop for some period and started to move in opposite direction like this? They have started to move in opposite direction. In that case, the electric current generated is also moving in opposite direction, and the magnetic field also will be in the opposite direction, right? So it all depends upon the direction of convection currents and their intensity. In which direction they are moving, that decides the direction of the magnetic field of Earth. If they are totally moving in opposite direction, it makes it totally reversed, which is experienced in the geological history of Earth, which we have seen in the geological history of Earth, that the magnetic field might undergo reversal. It is possible. Okay? So please write about this paleomagnetism. What is paleomagnetism? It is the historical study of Earth's magnetism in rocks. Historical study of Earth's magnetism in rocks. Full stop. When igneous magma crystallizes, the crystals of ferromagnetic minerals, for example iron, titanium, etc. acquire stable magnetism, which becomes frozen as the magma cools down. Full stop. This acquired magnetism is called as fossil magnetism. This acquired magnetism is called as fossil magnetism. Next paragraph. Such rocks will have ferromagnetic minerals aligned in the same direction, as that of geomagnetic field at the time of its consolidation. at the time of its consolidation. Next paragraph. When paleomagnetic evidences for a given region was checked over a long period of time, a gradual change in the direction was detected. Full stop. It shows that the position of magnetic poles has moved steadily over time. Full stop. This movement is called as polar wandering. Next point, next paragraph. During the study of oceanic surface, it was found that some rocks pointed towards north. And some towards south. Full stop. It is inferred that the rocks didn't change their polarity. But it is the Earth's magnetic pole that reversed its polarity. Next paragraph. Such reversal of magnetic field can be brought by reversal of convection currents. In the outer core. Full stop. This happens every 200 to 300,000 years. Every 200 to 300,000 years. That is 2 to 3 lakh years. Once in every 2 to 3 lakh years. So Prashant has a doubt, sir, does this reversal occurs due to the change in the direction of rotation of Earth? Is it possible? It is not possible because Earth cannot change the direction of rotation as such. It is highly unlikely that the Earth will change the direction of rotation, rather than the magnetic field has reversed. Magnetic field reversal होना easy है than the change in the direction of Earth's rotation. वो क्यों होगा, कैसे हो सकता है, ये तो possible ही नहीं है. It is not possible at all that Earth can change the direction of rotation. It will have huge catastrophic impact on the Earth if at all Earth changes the direction of rotation. Okay, there is a small concept associated with the magnetic field called as aurora. Aurora. Magnetic field as such, it's a very simple concept. ज़्यादा डिटेल में जाने का जरूरी नहीं है. This is the only question which has been asked till now. Okay, you can see in 2018, this was the question. वो भी दो स्टेटमेंट तो अलग ही एवोल्यूशन के बारे में, एक बस एक सिंपल स्टेटमेंट आ गया रिगार्डिंग द मैग्नेटिक फील्ड. व्हाट इज द आंसर हियर? एंड मोreover मैग्नेटिक फील्ड का भी देखो, जो भी वट एवर आई एक्सप्लेन्ड, दिस इज बेस्ड ऑन द करंट अंडरस्टैंडिंग ऑफ मैग्नेटिक फील्ड, है ना. एंड मेनी ऑफ द थिंग्स आर स्टिल evolving in this area. We are yet to clearly get the exact mechanism of evolution of magnetic field, कैसे evolve होता है, कैसे वो चेंज होता है, ये पूरा क्लैरिटी अभी मिला नहीं है. ओके, दिस इज ब्रॉडली एक्सेप्टेड थियरी दैट ऐसे होना चाहिए, दिस इज हाउ इट शुड हैव बीन जनरेटेड. बस इतना समझ लो एंड उसका मैकेनिज्म मतलब बिहेवियर समझ लो, दैट वुड बी सफिशिएंट फॉर जनरल स्टडीज. व्हाट इज द आंसर हियर? So majority of you are saying that the answer should be C, where few of you have given the answer D, A, B. चलो देखते हैं. So we have a majority says that it is C. First statement, Earth's magnetic field has reversed every few 100,000 years. That is totally right. अभी बताया था. First one is right. Second one देखो, when Earth was created more than 4,000 million years ago, there was 54% oxygen and no carbon dioxide. This was totally wrong. है ना, ऑक्सीजन तो बहुत कम था, हमने देखा है. So second statement is wrong. We are left with 1 only and 1 and 3 only. So third one देखना पड़ेगा. When living organism originated, they modified the early atmosphere of the Earth. That is totally right. That is how they increased the percentage of oxygen in the Earth's atmosphere, right? Through photosynthesis. Third statement is right. Answer is C. बस यही एक क्वेश्चन आए अभी तक मैग्नेटिज्म, जियोमैग्नेटिज्म के ऊपर. So don't worry. So let's talk about a phenomenon called as aurora. Recently एक न्यूज़ में भी था aurora बोल के. So let me just discuss. Usually I discuss this in climatology because you need to understand about the atmosphere. Okay, let me briefly tell you. यहाँ पर ज़्यादा कुछ doubt आ गया तो please wait करो till climatology. See Earth, this is Earth, and Earth is surrounded by a very thick atmosphere. The Earth's atmosphere goes up to the distance of, it goes up to the distance of nearly 64,000 kilometers. And please stop raising your queries in the query response portal. Response portal is just to give your answers. नहीं यहाँ पर use नहीं करने. I am repeating you again. So please don't raise your queries in the response portal. This is the Earth, and Earth is surrounded by a thick atmosphere. Within the atmosphere there is a layer in the outer part of the atmosphere. Okay, one layer in the outer part of the atmosphere, almost at the end of the atmosphere. We call it as magnetosphere. Okay, we call it as magnetosphere. So magnetosphere, what is magnetosphere? Magnetosphere contains the charged particles, electrons, protons, which are derived from the solar wind and are trapped in the Earth's magnetic field. Okay, अभी के लिए इतना समझो. This is a layer of atmosphere with charged particles of electrons and protons which are trapped in the Earth's magnetic field. Magnetic field में फंस गया है. फंस गया नहीं है, actually हमें protect कर रहा है. It protects us from the outer harmful radiation. वो कैसे समझाऊंगा. Okay, we have a layer of Earth's atmosphere. We call it as Earth's magnetosphere. Okay, in the atmosphere we have one separate layer, magnetosphere. So in this magnetosphere, whenever from sun hot storms of atom with highly charged particles are released and they move towards the earth, because because ये जो sun's electromagnetic radiation ना, it is not just visible light. उसके अंदर बहुत सारा other component है. We know that X-rays, gamma rays, UV rays, IR rays, है ना, radio waves, microwave, बहुत सारा है. इसके अलावा sun also releases hot storms of atom with a highly charged particles. And these hot storms of atoms with highly charged particles, if at all they are entering the earth directly, that will have a huge impact if they reach the earth's surface. उसको block करता है हमारा magnetosphere. Earth's magnetosphere totally blocks it, and this is generated due to the earth's magnetic field. Okay, along with the magnetosphere, even the earth's magnetic field, ये जो magnetic field है ना ऐसे, sorry, earth's magnetic field, it deflects these charged particles which are coming from the solar wind. उसको continuously deflect करते जाता है. But across the entire part of the earth, wherever these hot charged particles are hitting the magnetic field at right angles or in some angle, they will get deflected, but some of them will be able to reach the polar regions, both the north pole as well as south pole, where the magnetic fields are not in perpendicular direction, they are straight to the surface, because these magnetic lines are entering or emerging out of the surface like this, right? तो एक जगह में concentrate होगा in north pole and south pole. So near to the north pole and south pole, where the magnetic lines are straight, these charged particles, only some part of the charged particles from the solar wind gets trapped here near to the polar regions. Only some part. It will not cause any damage at all, but they get trapped near to the polar region, both in the north pole as well as south pole. And because of these charged particles in the north pole and south pole, it releases some beautiful colorful light. These charged particles, they interact with the Earth's atmosphere and they release the colorful lights. And these colorful lights which are released in the polar region, we call it as aurora. I hope you have seen about auroras in internet pictures में देखा होगा. These are the auroras. Okay, this is how auroras look like. These are very colorful, beautiful lights, but are visible only in the polar regions. If it is found in the north pole, it is called as aurora borealis. If it is near to the south pole, it is called as aurora australis. So aurora events कब ज्यादा होता है? Whenever there is more charged particles, ज्यादा charged particles atmosphere enter कर दिया, that increases the aurora, right? Higher charged particles, when they enter, usually they are blocked by the magnetosphere and the Earth's magnetic field, but some of them come near to the polar region. Okay, there is a small representation to show that. Okay, see this? This is how the charged particles are coming out of the solar surface. Storm of charged particles are coming out of the solar surface, and they are moving in all the different possible directions, and some of them are coming towards the Earth. Okay, and this is Earth's magnetic field, and these storm of charged particles, the Earth's magnetic field is able to block them, but not near to the polar regions. Polar regions mein na, they will not be able to block, only some part of it will come near to the polar region, and here you will find the beautiful colorful lights called as auroras. Due to the interaction of these charged particles with the Earth's atmosphere, it releases a colorful light. So near the north pole it is aurora australis, and near to the south pole it is, near to the north pole it is aurora borealis, near to the south pole it is aurora australis. One of the very beautiful phenomenon. Anyone who is interested in geography, environment would love to watch this. Okay, let's hope that we will also get an opportunity to watch this one day. अगर opportunity मिला है, particularly जो हमारा forest service में जाने वाले हैं ना, so you might get that opportunity. So we all need to experience such things. So that is auroras. Okay, please write briefly about this. Auroras, what are auroras? The magnetosphere of atmosphere magnetosphere of atmosphere blocks the charged particles from solar winds. Full stop. But some of these charged particles get trapped near polar regions where the magnetic lines where the magnetic lines are straight, where the magnetic lines are straight. Full stop. Due to the interaction of charged particles, in the Earth's atmosphere, near polar regions, beautiful colorful lights are released. Called as aurora. Full stop. It is called as aurora borealis. Aurora borealis in the North Pole. Aurora australis in the South Pole. याद रखना इतना मुश्किल नहीं है. Australis means south. Australis means south. Okay. Australia is basically, that means the continent of south. ऑस्ट्रेलिया से तो याद रखना चाहिए आप लोग. That is aurora. So any doubts here? Let's move on to the next topic, earthquakes. How solar flares impact auroras? अगर suddenly there is a huge amount of solar flares, that means if it is releasing a sudden hot storm of gases, it will contain higher charged particles, and higher the charged particles, more charged particles will interact with the Earth's magnetic field, so that might result in more spectacular auroras, ज़्यादा in a larger proportion. And they might become frequent, and usually auroras are visible during the winters. Why? Summers में तो पूरा polar region is 6 months of day है ना, daylight is bright, so day में नहीं दिखता है, it should be winter, night में दिखता है. So usually during the winters, either in the North Pole or South Pole, you will find these auroras. So solar flare के वजह से aurora का intensity थोड़ा सा बढ़ सकता है. We might observe frequent auroras. I guess almost all of you have experienced earthquake at least once. कोई ना कोई तो कभी ना कभी तो feel हुआ होगा earthquake. If not, I would say please experience at least once, because earthquake is so one of the way you can experience the raw force, the raw energy of nature. Right? It is one of the very beautiful experience, earthquake, if at all you have observed. Of course, one of the dangerous, as I told you earlier, beautiful things are also dangerous, खतरनाक भी हो सकता है. You know what happens during the earthquakes? Why do we call it as earthquake? Quake मतलब क्या है? shaking, vibrations, right? Earthquakes is basically the vibrations which are felt on the surface of earth, which we feel on the surface of earth. Why do we feel the vibrations on the surface of earth? It's because of the way lithosphere is there. So what is lithosphere? Lithosphere is basically the crustal columns of rocks. There are huge columns of rocks like this, right? Lithosphere is totally rocky layer, right? And the lithospheric layer, entire Earth's outer layer, particularly you take any particular cross section of lithospheric layer, it maintains a kind of equilibrium. A static equilibrium is maintained in the lithosphere. Right? That is required in order to ensure that stability. Whenever the lithospheric plates move, it moves as a one single unit, but that does not mean that the entire lithosphere is one particular single slab. इसके अंदर बहुत सारा छोटा छोटा सा layers रहता है. The rocks are aligned at all the different levels and all try to maintain the stability, right? But that stability is disturbed by some events sometime. That is due to the build-up of energy in some parts of the Earth's interior. If it is one particular single slab where there are no cracks, where there are no different layers, all of them move together as a single slab, and if at all you are pushing from one end, energy यहाँ पूरा से इस तरफ से आ जाएगा. But since the entire lithospheric slab is made up of different layers, different rock layers, different strata, if you put some energy from one end, some of the energy will get assimilated within the rocks and some of them will come on the other end, right? Overall, whatever the static equilibrium which these rocks are maintaining, that will be disturbed by the build-up of energy sometimes. And particularly this is more frequent in those regions where the two different parts of the lithosphere are rubbing against each other. They are either moving towards each other or moving away from each other, or they are moving across each other. In that case, there is more stronger build-up of energy. And this is a rocky layer, right? Rigid layer hai. It cannot keep on observing the energy for a continuous period of time. It will observe the energy for some time. It will hold the energy. But once it crosses certain limit, एक limit cross होने के बाद में suddenly it releases the energy, it bursts the energy in all the different possible direction. This sudden release of energy causes the shaking of the entire layer, entire lithospheric layer. That is what we call it as the earthquake. Why there is an earthquake? Why there is a shaking? Because there is release of some amount of energy in some part of the lower lithosphere. वहां पर energy is continuously building up. Energy कहां से आ रहा है? Because of the movement of the entire plates. All the plates are moving in continuous different directions. Not only the movement, there are various other reasons. Overall, the energy continuously builds up. It is not one single, one slab जैसे नहीं तो होता है ना. It is multiple layer, multiple rock layer, एक के ऊपर एक, एक के ऊपर एक. Because of which it allows for the build-up of energy, and suddenly at one point of time it snaps, causing the entire lithospheric layer to vibrate. That is what we call it as earthquake. Whenever there is earthquake, usually it happens in the lithosphere, because that is where the rocky layer is there. Okay, thoda kabhi kabhi, very rarely, even in the deeper parts also you will feel that is different. So let's say that the earthquake is happening here. near to the earth's surface. If this is where the energy is being built up and is being released in all the different possible directions, it releases energy in all the 360 degrees like this. It releases energy in all the 360 directions like this. Where would we experience the maximum intensity, maximum impact of this release of energy? If this is the point of energy of this is the point of release of energy, very near to this point, exactly above that, near to the surface, there is a point. Okay, इसी कोई हमारे पास अभी डिजिटल बोर्ड नहीं है. Let's say that I am zooming in. If this is the point where the energy is being released, just exactly above this point and nearest from the surface there is another point. Here you will experience the maximum impact of this release of energy. This point where the energy being released in all the possible directions, this is called as focus. And the point on the earth's surface which is nearest to the focus, of course we have all the different directions, in all the 360 direction may you will receive the energy. You will receive the energy released during the earthquake, right? But there would be one point which is nearest to the focus on the earth's surface. That point is called as epicenter. Focus is the point below the earth's surface, epicenter is above the earth's surface. Focus is the point where the energy is being released, epicenter is the point where the energy is being felt by human beings. That the release of energy is being felt by human beings. How do we feel that release of energy? Through the vibrations. That means if you are standing on the epicenter, you will feel the maximum vibration, because you are just standing above the focus. But that does not mean that the vibrations, the energy is released only in this point. Energy goes in all the 360 directions, 360 degrees of direction, but it is not felt. Usually it is felt in a narrow region around the epicenter. Epicenter के आसपास में पता चलता है, बाकी दूर जाते जाते उसका इंटेंसिटी कम हो जाता है. We will not be able to feel that. However, using different instruments, we will be able to record that. We will be able to record the different waves of energy released during the earthquake. वो तो possible है, हमें feel नहीं होता है, but the instruments can record it. Overall, these vibrations which are felt near to the earth's surface, caused by the transient disturbance of the elastic equilibrium which has existed in the lithospheric rock layers, is called as earthquake. The point where energy is released in the lithosphere is called as focus, and the point just above the focus, nearest to the focus on the surface, is called as epicenter. And the entire study of earthquakes we call it as seismology. The entire study of earthquake is called as seismology. Is that clear? That is what is earthquakes. Please write about this. What is earthquake? Vibration or oscillation of the earth, vibration or oscillation of the earth caused by a transient disturbance, of elastic or gravitational equilibrium, of the rocks at or beneath the surface of earth, at or beneath the surface of earth. Full stop. The scientific study of earthquakes The scientific study of earthquakes is called as seismology. Scientific study of earthquakes is called as seismology. Next paragraph. The point below the earth surface, the point below the earth surface where energy is released during the earthquake, is called as focus. Focus or hypocenter. Focus or hypocenter. ऊपर रहेगा epicenter. Okay, epicenter is above, hypocenter is below. So next one, epicenter. It is a point on the surface. It is a point on the surface which is nearest to the focus. Nearest to the focus. Causes of earthquakes. Earthquakes are caused both by natural reasons as well as anthropogenic. Okay, please write this as it is, इसमें dictation नहीं होगा. Natural and anthropogenic. What are the natural causes of earthquake? What causes the vibrations which we feel on the earth surface? सबसे पहले हमने already discuss कर लिया plate movement. Plate movement causes the vibrations. Any type of plate movement. All the three type of plate movements causes the vibrations on the earth surface, right? Because they have maximum chances of getting interlocked. While the plates are moving, they get interlocked very easily and energy builds up and suddenly snaps. When the most common cause of earthquake across the globe, 90% of the earthquakes across the globe are caused by the plate movement only. When the most common cause, क्या क्या plate boundary होगा? Divergent, convergent, transform. Divergent में ocean divergence, continent divergence. दोनों में there are earthquakes. Along the mid-oceanic ridges also, you will feel the earthquakes. Along the rift valleys also, you will feel the earthquakes. Convergent plate boundary, ocean convergence, western part of Pacific Ocean. Ocean continent convergence, eastern part of Pacific Ocean, both one of the deadliest earthquakes. Continent convergence, again earthquakes. Transform, सबसे deadliest है transform, conservative plate boundary, right? All the type of plate movement causes earthquakes. Other than that, are there any natural causes of earthquakes which cause the vibration of the upper layers? बताइए. Any natural cause of earthquakes other than the plate movements? What causes the vibrations on the top layer of the earth? Anyone? Are there any other? Natural causes of earthquakes. Your response portal is enabled. You can give your responses. Natural causes. थंडर से तो नहीं होता है, इतना भी ज्यादा वाइब्रेशन फील नहीं होता है. वी फील द वाइब्रेशन इन द एयर, नॉट ऑन द अर्थ्स लेयर. ठीक है, चलो थंडर मान लेते, बहुत लाइट हो सकता है, बट नॉट ऑन द अर्थ सरफेस. आई एम टॉकिंग अबाउट द नेचुरल कॉजेस, सो वी कैन नॉट इंक्लूड माइनिंग हियर. Magma, you cannot just say magma for everything. You should clearly specifically say what causes the generation of earthquakes. Mantle plumes, we don't feel as such mantle plume. ऐसा नहीं है कि magma निकल के आ गया, mantle plume बोल सकते. सार्थक, good. Volcanism, more specifically volcanic eruption. Volcanic eruption. Okay, whenever a volcano explodes, not shield volcano. Shield volcano से नहीं बनेगा earthquake. Okay, suppose there is a stratovolcano, composite volcano which has got its vent blocked and suddenly it violently explodes. The entire surrounding region will feel the vibration. पूरा vibrate होने लगता है. So that is what is volcanic eruption. Volcanic eruption can cause earthquake in the surrounding region. Possible है, good. और बताइए देखते हैं. I'm specifically talking about the natural ones. Some of you are giving anthropogenic, so please be specific. Yes, very good, Yash. He is saying meteorites. The impact of meteorite can cause the vibration of the earth surface because it is coming at a very fast speed. When it impacts the earth surface, suddenly it causes the vibration. Definitely, yes, meteoritic impact. और कुछ landslide, Santosh Bhindra, totally right. If landslide happens in a large scale, if any of you are living in mountain regions, you would understand, मतलब experience किया होगा. Okay, if there is a huge landslide, the entire side of the mountain will start to shake, it will start to vibrate. That's totally right. Okay, landslide हो गया, eruption of volcano, meteorite. Fault line is related to the plate movement only, so I don't see any other. Subduction, subduction is again related to the plate movement. No, I don't see any other answers. You can also add subsidence of land. Subsidence of land. Subsidence में क्या होता है? Collapse हो जाता है. Okay, maybe some kind of mountain or hill, है ना? And it suddenly collapses. That is what we call it as subsidence. Sudden collapse or subsidence of land causes landslide. And tsunami will not cause, it will cause earthquake. Tsunami will not cause earthquake. Earthquake will cause tsunami. So you cannot include tsunami as the reason behind earthquake. These are the natural causes. Anthropogenic means man-made causes. Already बहुत लोगों ने बोल दिया है. Mining is one important cause of earthquake. In those regions where there is underground mining is happening, है ना, अंडरग्राउंड माइनिंग के वजह से ये जो लोअर लेयर्स है ना, इट हैज बिकम टू वीक एंड यू कंटिन्यू द ड्रिलिंग इन लार्ज स्केल और एक्सकवेशन इन लार्ज स्केल, द एंटायर रीजन विल स्टार्ट टू अंडरगो वाइब्रेशन होने लगता है. माइनिंग एंड ब्लास्टिंग के वजह से जो वाइब्रेशन फील होता है, दैट इज व्हाट इज एंथ्रोपोजेनिक, वन ऑफ द इंपॉर्टेंट कॉज ऑफ एंथ्रोपोजेनिक earthquakes, anthropogenic derived earthquakes. Then nuclear explosions, of course in a large quantity. If you are exploding the bombs and all, तो वहां पर तो वाइब्रेशन तो फील होगा ही. एंड मोस्ट इंपॉर्टेंटली RIS, RIS. ओके, माइनिंग के साथ में चलो कंस्ट्रक्शन भी ऐड कर लेते, कभी कभी लार्ज स्केल कंस्ट्रक्शन ऑल्सो कॉजेज द वाइब्रेशन. RIS means reservoir induced seismicity. Reservoir induced seismicity. Reservoir induced seismicity. So what is RIS? इसके बारे में थोड़ा सा बात कर लेते हैं. चलो, reservoir induced seismicity is basically a type of earthquake caused by the building of reservoirs in large scale. Okay, that is due to the construction of dams. See, whenever we construct dams, it is very important that we analyze the rocks in the region in which we are going to construct the dams. So when you build dam, usually we will store the water. Okay, this is the dam. When water is stored by a dam, and remember this is a huge quantity of water, a huge column of water is being stored here, and this water is stored for a very long period of time. ऐसा नहीं है कि एक दो दिन के लिए, पूरा साल भर ऐसा ही रहता है. First of all, there is a huge weight of the dam on these rocks. Second, in addition to that, there is a weight of this huge water column on these rocks, जो नीचे है rocks. If at all these rocks are not strong enough to hold on to this weight, if at all they are not strong enough to hold on to this weight, this causes the shock waves in the entire region. The entire region starts to vibrate here like this, because the weight is too much. The rocks are not strong enough to hold on to this weight. है ना, the rocks are not strong enough to hold on to the weight of the water column as well as the weight of the dam. ये कभी कभी गलती होता है. ओके, बेस्ट एग्जांपल हमारा कोयना डैम ऑफ महाराष्ट्र. महाराष्ट्र में देयर इज दिस कोयना डैम, कोयना रिवर, इट इज अ ट्रिब्यूटरी ऑफ कृष्णा. तो वहां पर एक डैम कंस्ट्रक्ट कर लिया, बाद में पता चला द रॉक्स आर वेरी वीकर ओवर देयर. द एंटायर रीजन फ्रीक्वेंटली एक्सपीरियंसेस अर्थक्वेक्स. बहुत फ्रीक्वेंट है, उनको तो आदत हो गया होगा. इफ एनी ऑफ यू आर देयर फ्रॉम महाराष्ट्र, यू वुड हैव एक्सपीरियंस्ड इन द सराउंडिंग रीजन. Okay, that's because the rocks are not strong to hold on to this weight. इसकी वजह से the entire layer of the rock starts to vibrate. That kind of earthquake we call it as reservoir induced seismicity, RIS. So that's why usually dams and reservoirs are constructed in those regions where there are valleys, there are rocky valleys. Okay, so that it is easy to channelize the water as well as store the water along the rocky valleys, right? So these are the causes. We need to discuss more in detail about the earthquakes. It will take some time, so let's continue in the next class. Okay, in the next class we'll talk about the different earthquake waves, shadow zones, and measurement of earthquakes, along with the impact of earthquake, most important impact, that is tsunami. Okay, Sarthak has a doubt, sir. As we saw in the video, earth magnetic field is constricted to one end and dilated on the other. That's because of the solar wind. Solar wind causes एक साइड में थोड़ा सा constriction हो जाता है, दूसरे साइड में it gets elongated. So any other doubts? I guess rest everything is clear. ऑनलाइन क्लास थोड़ा सा स्लो हो जाता है बिकॉज आई विल नॉट बी एबल टू जज हाउ फार यू आर एबल टू अंडरस्टैंड. सो थोड़ा सा आपका कोऑपरेशन चाहिए इसमें. सो विल ट्राई टू पिक अप द स्पीड ग्रेजुअली and let's hope that the situation becomes better and we'll be able to have offline class very soon. ठीक है, so we'll continue in the next class. Thank you very much.